Welcome to video 2.3 in our first Principles of Astrophotography series. In this video, we discuss parallax, which is a technique for determining distances to nearby stars.
Why might I want to know distances to stars?
Because understanding the scale of the universe helps you better appreciate where we humans fit.
That's so zen.
Thanks.
This video is based on section 2.3 of our first Principles of Astrophotography book, which is linked in the description below.
I'm Boyd Edwards.
And I'm Ren Edwards.
Let's talk sensor sensibility.
Principle 12, parallax application. Distances to nearby stars can be determined by measuring small shifts in their positions against the background of distant stars, a technique called stellar parallax.
So this is how it works. This is the Earth in orbit around the Sun, and on two different sides of the Earth's orbit around the Sun, if you're looking at a nearby star, and then this is the background of distant stars, then when you look at it from this perspective, your line of sight is projected against this spot on the background of stars, whereas when you're on the other side of the Earth's orbit around the Sun, over here, 6 months later, right, then your line of sight toward that nearby star is projected against a different spot on the background of distant stars. So it's projected, anyway, there are two different spots. I'm not sure these really are that helpful, but you can see that there's two different spots where they're projected against the distant stars. One way to do this experiment is to do it yourself, and that's to hold your thumb out in front of you. Try this, Ren. Hold out your thumb in front of you. Close one eye. Say close the left eye, for example, and then open your left eye and close your right eye, and ask what happens to your thumb against the background.
It's dancing a little jig.
So it's going back and forth depending on which eye you look at it from, right? So now do that same experiment, but with your thumb closer, maybe a foot away from your eye, and do the experiment again and see if it's shifting more or less than it was before.
Yeah, totally.
So you see the shifting more?
Mm-hmm.
So you guys can't see it from your perspective. You have to hold up your own thumb and look at it against the background of
this is the audience participation.
Yeah,
portion.
this is where, and it's really useful to do that. So the closer this is the nearby star that we're replicating with the thumb, and the background of distant stars is that wall that the books are against there. And so the closer the star is, the more it hops back and forth, the more the parallax, and you can use that to determine the distance to the star.
Parallax. 13. Parallax definition. The parallax is defined as half the angle between the two lines of sight toward a nearby star, as seen from 2 points on opposite sides of Earth's orbit.
So here's that same diagram as before. Now we're doing a little bit more precise mathematical definition of parallax. It's half the angle between these two lines of sight, this one and this one. So if we draw a dotted line from the Sun toward that nearby star, then the parallax, P, is half the angle. So there's an angle P from here to here. Here's an angle P from there to there. And this total distance is theta that we talked about before in a previous video. So if theta is the angle between those two lines, which it is, then P is theta divided by 2. And that's just how it's defined. One other thing that I might say about parallax is that you can use parallax to measure distances to stars up to about 10,000 light years away. We talk about this and do some examples in our book, but it's great for measuring distances to nearby stars. The far away stars, you're out of luck. You're going to have to use Cepheid variables or some other technique, but it's great for measuring distances to nearby stars. Thanks for watching.
And we'll see you next time.